I will begin with the introduction and overview of the Xray unit. Let me introduce my group members. My group consists of Munira, Nur Sharafina, Afika Azahra, Nur Christina Fatiha, and Nurin Sophia. The Xray unit is a medical imaging system used to produce X-ray image of the human body. This image helps doctors to diagnose disease, injuries, and other medical conditions. Now, I will briefly point out the main external components of an X-ray unit. First is the control panel, which is used to set exposure factors such as KVP and MAS based on the anatomical part that need to be examined. Next is X-ray tube, where X-ray are produced. This is the collimator, which limits and shapes the X-ray beam. Here is the patient table, which supports the patient during the imaging. Below or behind the table is the baki or image detector, which captures the X-ray image. Finally, the generator, which supplies electrical power to the system. This overview helps us to understand how each part works together to produce a diagnostic image. With that, now I will hand over to the next presenter.
Assalamualaikum and hi, my name is Mira binti Abdul Aziz, and for my part, I will explain about the main control on the control panel of the CR X-ray system. Okay, this is the control panel. The control panel allows the radiographer to select exposure factors and the examination program. As we can see, on the left side is the manual exposure factors, and on the right side is the examination program. Okay, this is the on-off button. Okay, on the upper side is the baki selections, and this one is the AAC chamber, and the symbol of a square is the focus spot of X-ray. This is for smaller focus spot, and it's a large focus spots. Okay, on display show two parts, which is the KV and the MAS. Okay, this arrow button is to increase and decrease the KV and the MAS. Okay, this allows the radiographer to fine-tune the exposure according to the patient size and the body part being examined. On the right side of the control panel, we can see a list of preset anatomical programs such as chest, ribs, the lumbar, the spines, cervical spine, thoracic spine, and lumbar spine. And we also can see the upper extremities and lower extremity as well. This program automatically select the complete exposure factors for each examination. They help standardize technique and reduce exposure error, especially for routine examination. Okay, this is the exposure button highlighted with a yellow circle. Okay, when the button is fully pressed, the X-ray exposure is made. KV represents the energy or strength of the X-ray beam. A simple way to understand how KV works is we can imagine the body part is like sponge, and KV is the strength or the energy of water pressure. Okay, the sponge have different kind of thickness. If the water pressure is low, only a few drops enter the sponge. If the water pressure is high, the water can penetrate the sponge more easily. So, in the same way, higher KV give the X-ray more energy, allowing them to penetrate thicker body parts. Then, how KV affect the image quality? High KV means more penetration with lower contrast. So, the PC will look similar. While lower KV means lower beneficial with higher contrast. It is better for distinguish both from history. Okay, next, the below part of AV is the MAS. Okay, the MAS controls the total amount of radiation or photon produced. MAS directly affecting image density and patient dose. Think of AMS as controlling the volume of X-ray beam. High MAS, more X-ray hit the patient, creating a brighter image with less graininess, but exposing the patient to more radiation. Low MAS, fewer X-ray, resulting in lighter image with more graininess but lower patient dose. Okay, so this control panel allows the radiographer to produce a clear diagnostic image while keeping the patient dose low. That's all from me. Thank you.
Assalamualaikum and hi everyone. My name is Instrumentation and for this session I will be explaining about the Xray tube, which is the main source for X-ray production in imaging system. This component is known as the Xray tube housing. Its main function is protect the internal components, reduce radiation leakage, and provide electrical insulation. The housing is filled with insulation coil, which helps with cooling and heat absorption during exposure. In the Xray tube, there are two main components. That is cathode and anode. For cathode, it contains a filament made of tungsten. When heat, the filament releases electrons through a process called thermionic emission, while the anode consists of tungsten target. When electrons strike the target at high speed, X-rays are produced. This is how it works in order.
Alright, for the next part, I will talking about a focus spot size. This is the focus spot. The area where electrons strike the anode is known as the focus spot. A small focus spot produces a sharper image but generates more heat. A large focus spot can tolerate higher exposure but produce slightly less image detail. This is why small spots are used for extremities while large focus spots are used for thicker body parts. Then there is the anode angle. The anode angle affects the effective focus spot size and the field coverage. Meanwhile, a larger anode angles allow a wider coverage but reduce image sharpness. That means small angle lead to better detail and larger angle lead to wider field. The Xray tube also has a tube rating, which indicates the maximum exposure factors that can be safely used without damaging the tube. This rating is closely related to heat production.
Understanding of the Xray tube structure and design, we can now appreciate why heat management is crucial, which will be explained further by Fatihah.
Assalamualaikum and hello everyone. My name is Fatihah binti Matisha. In this part, I will be explaining heat production, heat dissipation, and tube rating in the Xray tube. This is very important because most damage to the Xray tube is caused by excessive heat. Why heat is produced? When an exposure is made, electrons travel from cathode to anode target at very high speed. However, only 1% of the electron energy produces X-rays. The remaining 99% is converted into heat at the anode target. Why heat is dangerous? This heat is extremely intense and can damage the anode surface, crack the target, or even cause permanent tube failure. Once the X-ray tube is damaged, it is very expensive to replace and imaging service may be interrupted. How heat is dissipated? To prevent damage, the Xray tube is designed with several heat dissipation mechanisms. Firstly, the anode is usually made of tungsten, which has a very high melting point. Secondly, many Xray tubes use a rotating anode which spread heat over a larger surface area.
Thirdly, the tube housing contains insulating oil which absorbs and transfers it away from the anode. Some systems also use cooling fan to further reduce temperature. As radiographer, it is our responsibility to select exposure factors wisely. Repeated high MS exposure, short exposure intervals, or ignoring cooling tube can overload the X-ray tube. This is why proper technique selection and understanding tube limitation are essential in daily clinical practice. In conclusion, understanding heat production and tube rating is not just theory. It helps us protect the X-ray equipment, reduce downtime, ensure patient safety, and maintain high image quality. A knowledgeable radiographer does not only produce image but also protect the machine that produced them. That's all from me for this section. Thank you.
Assalamualaikum and hi everyone. My name is Radiographic binti Muhammad Sazli. Today I'm going to talk about the Xray generator and why it's one of the most important parts of an Xray system. So what exactly does the Xray generator do? The generator's main job is to provide high voltage to the X-ray tube. This high voltage is what accelerates electron from the cathode to the anode, so the X-ray can be produced. Without the generator, the tube will not have enough power to create any radiation at all. Now, let's quickly talk about the different types of generator found in radiography system. There are a few main types. First, single-phase generator. They were used in older machines. They produce fluctuating voltage, which means the X-ray output is not very consistent. This can lead to more noise and lower quality images. Second, three-phase generator. These improve the voltage stability. With less voltage ripple, they produce more consistent X-ray beams, leading to clearer images and more efficient exposure. And for example, here in Hospital Kampa, Perak, the Xray unit is equipped with a three-phase generator. The last one is high-frequency generators. These are the most common modern X-ray system today. High-frequency generator convert the input power into a very stable, smooth, and efficient high voltage. The result, better image quality, shorter exposure time, less heat production, and lower radiation dose to the patient. Because of these advantages, almost all current radiography machines use high-frequency technology. Now, how does the generator relate to the exposure pattern? As you guys can see, this is the control panel. When you select your KVP, you are basically telling the generator how much voltage it should send to the X-ray tube. The higher the KVP, means stronger, more penetrating X-ray. This is useful for thicker body parts like the chest or abdomen. Lower KVP means softer, less penetrating X-rays. Useful for thinner structures like the hand or wrist. So the generator doesn't decide anything on its own. We control it through the panel. The same goes for the MA, which means how many electrons are produced. Exposure time, which means how long the electron are accelerated. These three factors together with the generator determine the intensity of the X-ray beam, the contrast of the image, and the patient's radiation dose. You can think of the generator as the heart of the X-ray machine. It pumps energy through the system, and the KVP setting is like the pressure control that adjusts how strong the heartbeat is. When we set the KVP on the control panel, we are actually controlling how much voltage the generator sends to the tube. A higher KVP means higher energy X-ray that can penetrate thicker body parts, while lower KVP produces lower energy X-rays with less penetration. So in summary, the generator supplies the high voltage and the KVP setting determines exactly how much that voltage is used to create the X-ray beam. So why is all this important? A well-functioning generator ensures consistent image quality, accurate exposure, reduced noise, and better safety for both patient and radiographers. If the generator is unstable or faulty, you might get flickering exposure, underexposed or overexposed images, repeat imaging which increases radiation dose, or even complete failure to produce X-ray. This is why radiographers must understand what the generator does, even though we don't physically see it working behind the machine. In summary, the X-ray generator is the power source that drives the entire imaging process. It provides the high voltage needed by the tube, comes in different type of high frequency generator and works together with exposure setting such as KVP to create high quality X-ray images. Understanding the generator helps us appreciate how the machine produces radiation and why our exposure setting matter. That's all from me. Thank you.
Hi guys, my name is Narin Sofia, maintenance biology staff, and today I will explain about line focus principle. So, what is line focus principle? So, line focus principle works inside the X-ray tube. Line focus principle happens inside the X-ray tube. This is the tube housing, also called as X-ray tube. Line focus principle helps in improve image sharpness and prevent heat damage. This is the example of two different angle. As you can see here, the anode is angled. The angle is usually 6 to 20 degrees. Electrons hit a long area on the anode. This area called the actual focus spot. Because of the angle, the focus spot looks smaller. This is called the effective focus spot. A small effective focus spot gives a clear image. The actual focus spot controls heat. And the effective focus spot controls image quality. One limitation is anode healing effect. So this is cathode side and anode side. Cathode side has higher X-ray intensity and anode side has lower X-ray intensity. As you can see here, the cathode side represents the negative symbol and the anode side represents the positive symbol. So, why the anode side has lower X-ray intensity? Because here X-ray are absorbed within the anode heat. This is cathode side and anode side. X-ray intensity is higher on the cathode side and lower on the anode side. So why is anode side is lower X-ray intensity? It is because X-ray are absorbed within the anode heat. And for example, anode heat effect is abdomen X-ray. For abdomen X-ray, we put the thicker side of the body on the cathode side. As you can see here, this is the cathode side. It is because on the cathode side, it has a higher X-ray intensity for allow better penetration and high image quality. So, in conclusion, the line focus principle states that the X-ray tube uses a larger actual focus spot to tolerate heat, while producing a small effective focus spot to improve image sharpness. This is achieved by angling the anode target. Because of the angle, the focus spot appears smaller from the image receptor, even though the electron beam strike a larger area on the anode. In short, larger actual focus spot has better heat dissipation, while small effective focus spot has sharper image. This principle balance heat management and image quality in diagnostic radiography. That's all from me. Thank you.